Problem 1. There are two clocks in Kathy's room. One of them is 25 minutes behind. Now it's showing 7:40. The second clock is 15 minutes ahead. What is the second clock showing now? These are our options. First, let's figure out the correct time. The first clock is 25 minutes behind and the current time is 7:40. So to get an actual correct time, we would add 25 to 7:40, which gives us 8:05. So the actual time is 8:05. Now let's adjust the second clock. Since the second clock is 15 minutes ahead, we add 15 minutes to the actual time. So this gives us 8:05 actual time plus 15 gives us 8:20. So our answer is option E, 8:20. Problem 2. In 4 of the 5 pictures, the white area is equal to the gray area. In which picture are the white area and the gray area different? To use our best strategy, divide each picture into smaller pieces, compare the white and gray area carefully, look for differences. Does one shape have extra or missing parts? Let's do it with option A. We see small circle that's equal, matches the gray and white. Gray and white matches here, gray and white matches here. There is no difference. Option A is not our answer. Here gray area matches with the white area, white matches with the gray area. There is no difference. This is not our answer. Here we see white area matches with the gray area. Gray area matches with the white area and white matches with the gray. There is no difference. Option C is not our answer. We see here a gray area. It's supposed to be white. Does not match. It's white. Does not match with the white. It should be gray. And a gray ball matches exactly to the gray ball. It's supposed to be white. So this could be our answer. There's a lot of differences in here. Here we see gray, white matches. White matches with the gray. And this is not our answer because there is no difference. So our answer is option D, which has some differences. Let's move on to the next problem. Problem 3. Father hangs the laundry outside on a clothesline. He wants to use as few bags as possible. For 3 towels, he needs 4 bags, as shown. How many bags does he need for 11 towels? So let's start from here. For 1 towel, he needs 2 bags. For 2 towels, he needs 3 bags. For 3 towels, he needs 4 bags. Do you see a pattern in here? Every time we add a towel, we add 1 more bag. So if we have 4 towels, we would need 5 bags. So if we need 11 towels, we would need, yes, 12 bags. So our answer is option B, 12. Let's move to the next challenge. Problem 4. A math class lasts 45 minutes. Peter can solve any problem from the textbook in exactly 6 minutes. However, he needs 1 minute rest after solving each problem. How many problems can Peter solve completely during one math class? These are our options. Peter is in a 45-minute math class. He can solve 1 problem in 6 minutes, but he needs a 1 minute rest after each problem. So solving 1 complete problem, he would need 6 plus 1 minute. That is, 1 complete problem plus resting time takes 6 plus 1 is equal to 7 minutes. So how many problems can he solve now? We now divide total class time 45 minutes by the time for each problem, that is 7 minutes. So 45 divided by 7 gives us 6, remainder 3. So Peter can only finish one complete problem, and we round down to 6 full problems. So he will have 3 extra minutes left, but that's not enough for another full program. So our answer is 6 full problems. That is option D, 6. Problem 5. 15 children are playing hide and seek. One of them is the seeker. After a while, 7 children were still hiding. How many children have already been found? These are our options. 15 kids are playing hide and seek. One children is the seeker, which means one child is finding the other. And what does this mean? That leaves 15 children who are hiding. So 15 minus 1 gives us 14. So the 14 are hiding. The 15th one is a seeker. So we remove 1. Now we know how many total hiding. Now we started with 14 hiding children, and it says 7 children were still hiding. That means we take out 7 children. So 14 children are hiding or found. 14 minus 7 gives us 7. So we removed the 7 children still hiding. We take it out 7. Now we have to say how many children have already been found. That means 7 children are found. Our answer is option D, 7. Problem 6. Mike and Jake were playing darts. Each one threw 3 darts. See the picture. Who won and by how many points did he win? These are our options. First, let's look at the score for each player. So for Mike, we have 25, 35, and 7. For Jake, we have 15, 45, and 3. So what's the total score for both the players? 25 plus 35 plus 7 gives us 67. For Jake's, we have 15 plus 45 plus 3 gives us 63. Now who won? Mike won. By how many points? 67 minus 63 gives us 4, by 4 points. Now let's see the options. So we'll take out all the options which says Jack. So we take out this, we take out option D. Now Mike, he scored 3 points. More? No. Mike, he scored 2 points more? No, we know it's 4 points. So answer is option E. Mike, he scored 4 points more. And this is our answer. Problem 7. A regular rectangular pattern on a wall was created with 2 kinds of tiles, gray and striped. Some tiles have fallen off the wall. See the picture. How many gray tiles have fallen off? Let's look at each column and observe how many gray tiles are supposed to be there. So the gray tiles in each column should be here 3. It's supposed to be 2 in here. We have 1 and then gray here, and that's gray 3. Similarly, the next 2 should be 3, should be 2, 3, 2. Now let's figure out how many gray tiles are missing from the fallen tiles. So first column, there are 3 tiles, so nothing is missing here. Second column, there should be 2 gray tiles, but we see 1 gray tile, so 1 gray tile is missing. Third column, there should be 3 gray tiles, but we see only 2 gray tiles, so 1 gray tile is missing. Fourth column, there should be 2 gray tiles, but do not see any, So all 2 gray tiles is missing. Next column. There should be 3 gray tiles, but we see 2 gray tiles left, so 1 gray tile is missing. There should be 2 gray tiles, but do not see any, so all the 2 gray tiles is missing. There should be 3 gray tiles, but we see only 2 gray tiles left, so 1 gray tile is missing. 8th column, nothing is missing, so we mark it as 0. Now add the missing gray tiles. 0 plus 1 plus 1. 2, 2 plus 2, 4, 4 plus 1, 5, 5 plus 2, 7, 7 plus 1, 8. And our answer, 8 missing tiles are there. So option B is our answer. So if you would like to see all the tiles attached, this is your slide. Problem 8. The year 2012 is a leap year. That means there are 29 days in February. On the 15th of March 2012, the ducklings of my grandfather are 20 days old. When did they hatch from their eggs? These are our options. Let's bring our calendar and look into solving the problem. To find out when the ducklings hatched, we will count backwards. We will count backwards from 15th March to 1st March for now. So how many days are there? We have 15 days in here. Now February 29. So this is a leap year, so we have February 29. That's our 16 days. February 28 is 17. February 27 is 18. February 26 is 19. February 25 is 20 days. So the ducklings hatched 1 day earlier than the 20th day. So therefore, they must have hatched on 24th February. So our answer is February 24, option D. This wraps up part A of the first 8 questions from the 2012 Math Kangaroo for grade 3 and 4. Make sure to like, subscribe and hit that bell so you never miss a new challenge. See you in the next problem solving adventure. Stay tuned for part B of the 2012 Math Kangaroo for grade 3 and 4. Thank you.